This is naming covalent compounds, which is in Chapter 9 of your book. So just to give you a frame of reference, ionic compounds and ions are Chapter 7, covalent molecules are Chapter 8, and covalent naming is Chapter 9. So that is a good way to get a scope of the unit that we're dealing with right now, which is atomic bonding between atoms. So covalent naming is actually a pretty complex thing. It can be a little confusing because you can have more than one name for the same molecule. So O2, a diatomic gas, can either be called dioxide or oxygen gas. Those of you who go on in chemistry into your college years, so not even really AP, but college level chemistry, you may take a course called organic chemistry, which deals with covalent compounds that contain the element carbon in them. A whole part of organic chemistry is being able to look at an organic molecule and figure out what the name is. And so you spend a lot of time in organic chemistry on naming different organic molecules. However, because this is not organic chemistry, we're going to kind of stick to the easiest ones. So we're going to stick with simple binary covalent molecules. Binary meaning containing only two different atoms in them. Bi meaning two. We'll also deal with the diatomic gases such as O2 above, like dioxide or oxygen gas. But other than that, we're not even going to get into things like, we've been talking a lot about sucrose and glucose. We're not going to talk about how to name those, so you don't have to worry about it. So the way we're going to name binary covalent molecules is exactly like a type 1 ionic compound. So that's like NaCl, remember, without transition metals. Except that we are going to include prefixes for the number of atoms of each type. And a little later in this video, I'll show you why we include prefixes. So the prefixes we use are the number prefixes that you're used to, that a lot of you have even asked about. You've said, why do we say carbon dioxide, which is covalent, but we wouldn't say, let me see if I can think of something. For example, tin 4 dioxide. We don't say dioxide, we just say tin 4 oxide. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, and really in the scope of this course we're not going to see more than 6. There are other prefixes for 7, 8, 9, 10, and again, if you go further in chemistry, you'll encounter those and you'll need to know them, but you're not going to need to know more than 6 hexa for this course. There is an exception. Sometimes, especially on the first element, we don't use mono. So for example, CO2, carbon dioxide that we're all familiar with, we don't say monocarbon dioxide, we just say carbon dioxide, and we know that there's only one carbon. CO, carbon monoxide, notice we put the mono on the second element but not on the first. If on a test you were to say monocarbon monoxide or monocarbon dioxide, I certainly wouldn't mark it wrong if you forget that little exception. So I want to talk a little bit about why we would need to use number prefixes in covalent molecules but not ionic compounds. And please make sure you understand this and know that I might give you a pop quiz on it. Actually, let's say this. At the end of these notes, I'm going to ask you a question. I want you to write down the answer to that question and turn it in for your homework tomorrow. Tomorrow being Monday, which is when these notes are due, regardless of when you're watching them. So let's take 3 different molecules, C2H2, C2H4, and C2H6. So this, from the outset, is the reason we need to use number prefixes, because notice each of these molecules is made from carbon and hydrogen. So if we simply called them carbon hydride, we wouldn't know which molecule was which, and let's say we're doing chemical reactions or we're trying to use one of these. If we use the wrong one, bad things could happen. You could get a bad reaction, you could end up with something poisonous when you thought you had something that wasn't poisonous. You could simply end up, whatever you wanted to have happen didn't work. Obviously, we need different names for different molecules. So the reason that you can have different molecules with the same atoms in them is because, remember, covalent molecules are sharing electrons. And so that can be very flexible. You can have single bonds, you could have double bonds, you could have triple bonds. So you can get a variety of different molecules using the exact same atoms. There's in fact another molecule that's CH4. So, and that's methane gas. And so that's yet another molecule with C's and H's. There are, I don't know, I think I saw something like 17 different molecules perhaps that contain C, H, and O in different ratios. Compare that, or I guess contrast that, to ionic compounds where you have a positive and a negative and they need to cancel out. So for example, you have NaCl. Na is positive, Cl is negative, so it's a 1-to-1 ratio. You can't have NaCl2 because then you would have 2 minus to the 1 plus, and that's not going to cancel out. Similarly, if you have sodium and oxygen, you would have Na2O because you would need 2 1 pluses to cancel out the 2 minus from the oxygen. So because ionic compounds bond in very specific ratios, there's only one way for them to bond. So you don't need to distinguish how many of each. You should know it just based on the formula. So moving a little further, here's where we use the prefixes to distinguish which of these compounds we're talking about. For C2H2, we say dicarbon dihydride because there's 2 carbons and 2 hydrogens. For C2H4, we say dicarbon tetrahydride because there's 2 carbons, 4 hydrogens. And for C2H6, we say dicarbon hexahydride because there's 2 carbons, 6 hydrogens. Moving a little further, as I said, these also have different names because dicarbon dihydride is a little bulky to say. So if we don't have to say that, why say it? So we can also use words, and this gets into a little bit of the organic chemistry I was talking about. So eth, the prefix eth, ETH, means 2 carbons. So notice each of these compounds has 2 carbons and they each start with the prefix eth. Then the ein, ene, and ane is talking about what kind of bonding goes on. So we've worked with some of these compounds over the past few days in drawing Lewis structures. We had the dicarbon dihydride as one of our examples in the covalent bonding notes. Ane of the C2H6 means single bond, meaning the 2 carbons, there's just a single bond between them. Ene of the C2H4 means double bond. So there's a double bond between the 2 carbons, and ein with the C2H2 means triple bond. So there's a triple bond between the 2 carbons. So ethine means 2 carbons with a triple bond between them. Ethene means 2 carbons with a double bond between them. Ethane means 2 carbons with a single bond between them. Then C2H2 can even be called acetylene. And so as you can see, any of these names, dicarbon dihydride, ethine, or acetylene, work for C2H2. We're going to stick, for the scope of this course, with the easiest dicarbon dihydride, although certainly knowing things like eth means 2 carbons, ein means a triple bond, can help you because you'll see these things written. You've maybe heard of certain other compounds. So ethane, perhaps you've heard of. Most of you have heard of propane. Pro means 3 carbons. So propane is a compound with 3 carbons and then hydrogens with single bonds between them. Butane, like a butane lighter, is 4 carbons with single bonds between them. And so you can start to deconstruct what these words mean to figure out what the different structures are. Another one that we've been talking about, we used ethanol in class. The ol suffix is for an alcohol. So we have ethanol, methanol, propanol. So ethanol that we used in class is an alcohol with 2 carbons, the prefix eth. And so these things all work together, and then you can decide or figure out what the structure is of those molecules. All right, so go ahead, we're going to do some examples. Go ahead and name CCl4. Pause the video, name it, and then check your work. For CCl4, you should have gotten carbon tetrachloride. Because it's 1 carbon, we rarely use mono on the first element, and then 4 chlorines. For CO2, carbon dioxide. This one we've talked a lot about. Again, rarely use mono on the first carbon, 2 oxygens, dioxide. H2O, and don't just say water. That would be dihydrogen monoxide, 2 hydrogens, 1 oxygen. And N2, and there are 2 names I would accept for this one. Dinitride would be 1, or nitrogen gas. If you recognize that as a diatomic gas, you could just call that nitrogen gas. So your homework is to write down why you need these prefixes like mono, di, and tri for molecules, covalent molecules, but not for ionic compounds, and give some examples to help back up what you're saying. And then secondly, and this is more extra credit, there are some ionic compounds that where you have the same elements bonding to different ratios. See if you can figure out which compounds those are and how we handle the naming of them. That part is going to be a little extra credit. See if you can get that part. But the first part I am going to collect, so kind of is too bad if you don't actually take the notes. Please feel free to put any questions you have on the comment section or email them. Have a good night.